Alrighty guys, hello. Welcome to topic 2.1, elasticity. It corresponds to chapter 5 in your textbooks. So a little bit of a recap before we dive into this next set of topics. So this next set of topics that are going to be covered on your second exam really gets into the microeconomics nature of things rather than just kind of some basic supply and demand. But we're going to work on that supply and demand model a little bit more in this topic and just really kind of dive deep into the microeconomic aspects of it. So this is going to be very similar in terms of using the law of demand and the law of supply. So the second bullet point here, the idea that price and quantity demanded have an inverse relationship. That's called the law of demand, that when price goes one direction, the quantity demanded moves the opposite direction, and it's why we have downward sloping demand curves. Price and quantity supplied have a direct relationship or a positive relationship. That means when price goes one direction, sellers supply more versus less. The quantity supplied goes the same direction as that price, and that's why we have upward sloping supply curves. So those concepts are going to be reflected in this topic again today and built off of. So we have three key questions. We're going to talk about what is the price elasticity of demand. We're also going to talk about something called price elasticity of supply, what determines it, and why is it significant. We're going to talk about how the two relate to one another, specifically in the context of taxes, and what are some other types of elasticity. So all about elasticity today. So before we dive right in, to kind of get into our definition of elasticity, I want you to think about two identical price increases for two different products, okay? Let's think about how we as consumers would respond to a 20% price increase in two different items. Let's say the price of a gallon of gasoline goes up by 20% and the price of a meal at Wendy's goes up by 20%. So maybe we could say, just for the sake of having nice round numbers, the price of gas at first, so we'll say the first price of gas was $2 a gallon. And then when the price of gas increases by 20%, so if you want to find 20% of anything, you just put 1.2 times whatever it is into your calculator. So if a 20% increase in a $2 price of a gallon of gas means the new price will be $2.40. Meanwhile, a Wendy's meal, let's say the price of Wendy's at first was, I don't know, $5 for one of their meal deals. And then the price of a Wendy's meal after the price increase, it's going to be 20% more than that, goes up to $6. Okay, so both of these represent an increase of 20%. Of course, 20% of $5 is a bit more than 20% of $2 just because it's higher to start off with. How would you respond, though, as a consumer? And you would respond to these two, according to the law of demand probably, you would buy less of both. However, you would probably buy a lot less of one and a little less of the other. And probably if I were to guess which one you would buy a lot less of, you'd buy a lot less Wendy's, right? Because you have other options. I'll just go to McDonald's instead, or I'll make my lunch at home. A 20% price increase in the price of Wendy's, I'm going to respond to that a lot more than I am going to respond to a 20% price increase in the price of gas in terms of how much I buy. Now, I'm going to be frustrated much more by this 20% price increase in gas because I have to pay for gas. I have to get to work, we have to get to school, we have to get to wherever we're going. There's a lot less flexibility here when it comes to gallons of gas versus Wendy's sandwiches. So that's kind of what elasticity explores. We have the same price increase here, but my response in terms of how much less I buy varies from item to item. And that's what elasticity is all about. So here's our definition to start us off. Elasticity, it's a concept that measures responsiveness. So I always like to think elasticity means sensitivity. So we know that when the price of an item goes up, it means we consume less. But the question that elasticity answers is how much less? We say it would be much less Wendy's sandwiches, not that much less gas. Okay, so price elasticity means price sensitivity, or how sensitive am I as a consumer in changing my quantity demanded when the price changes. Or we're going to talk about price elasticity of supply as well from a seller's perspective. How much does a seller change their quantity supplied when the price of the item they're selling changes? So the law of supply and demand told us what direction does quantity demanded and quantity supplied move when the price changes. Elasticity tells us how much in that direction does it change. So we're going to explore first price elasticity of demand, which we abbreviate here as E subscript D. It's kind of the most commonly discussed form of elasticity. People might just call it elasticity for short, but technically the full long name is price elasticity of demand, but they might just say it in part. They might say price elasticity or elasticity of demand, or just elasticity for a good or service, for Wendy's, for gasoline. But it just means the percentage change in the quantity demanded, or the amount people want to buy, divided by that percentage change in price. So how responsive are we? So generally, we describe demand as elastic or inelastic based on how sensitive we are to that change in price. So we say an item has elastic demand if the quantity demanded changes a lot in response to a price change. So it means that we have a sensitivity to price as consumers, or we are very responsive in terms of buying more or less depending on how that price fluctuates. Whereas something is said to have inelastic demand if the price of an item fluctuates, but it doesn't really change how much consumers respond by purchasing more or less. We're going to also have an equation for elasticity of demand. And so when we plug numbers into that equation, that percentage change in quantity demanded over percentage change in price, what we get as that number is going to help define whether or not demand is elastic or inelastic. Typically, the larger the absolute value of a number, the more elastic demand is, and the smaller of a value we get for elasticity of demand, we'll say that's more inelastic. So if we go back to that example that I opened with, we would say Wendy's has fairly elastic demand because we said we'd buy a lot less Wendy's when the price went up, so we're very sensitive or responsive to the change in price of Wendy's. Meanwhile, we'd say demand for gas is inelastic because we are insensitive or unresponsive because we still have to get to school, work, etc. All right, so there are 5 determinants for a good or service that will determine how elastic their demand is. So these are the 5 characteristics, and we'll talk about them each in detail. So the first one is the availability of substitutes. So the availability of alternatives helps determine how sensitive I can be because it lets me know what are my other options here. If an object or if a good or service has many substitutes, we say we are more elastic, more responsive to a price change. So just like with Wendy's, there's a lot of substitutes for a Wendy's meal. I could go to McDonald's or Burger King, some other fast food place, some other food altogether. There are many, many substitutes for an item, so we have pretty elastic demand. The price matters a lot for products with a lot of substitutes. If an item does not have a lot of substitutes, we say it has pretty inelastic demand. So another set of examples here. If we were to compare Granny Smith apples to insulin, there are a lot of substitutes for Granny Smith apples. We could buy other brands of apples. We could buy other fruit. For the most part, most people are not dead set on buying Granny Smith apples. So because this item has lots of substitutes in most consumers' minds, we would say Granny Smith apples has pretty elastic demand. Meanwhile, insulin, if you're diabetic, you need insulin to process blood glucose, and there's not any real alternative to it. So we'd say regular insulin is going to have pretty inelastic demand. There's not really a lot of substitutes here. All right, the second characteristic that helps determine how sensitive we are to a price change in a good or service is going to be how much of my budget am I spending on that good. This one's a little bit counterintuitive to a lot of people, but basically, if I have a very expensive item or a big ticket item, something that is a large share of my income and my budget, I'm going to notice those price fluctuations more, and so my demand is going to be more elastic. So, for example, if we had a 20% discount on iPhones, more people would be very interested in going to buy a new iPhone because 20% of the price of an iPhone is a huge amount of savings. Vice versa, if we talk about very inexpensive items like a pack of gum, if I said Extra is having 20% discount on their packs of gum, I don't care as much, right? Because Extra is not something that I really budget for. I buy a pack of gum every once in a while, not too expensive. A 20% decrease in the price means we're talking like a few cents maybe. So I have more inelastic demand here because I don't respond to that price change as much. Whether a good or service is a necessity versus a luxury. If it's a luxury, it's not something we necessarily need. So I'm going to care more about the price if it's a luxury item like a vacation, like going out to dinner, a fancy boat, jewelry. We're more sensitive to price changes in luxury items. Whereas if something is a necessity like our electricity bill, right? We pay our electricity bill here in Florida. Whether it's cheap in the winter or expensive in the summer, we are not very responsive to price changes because we need it. We need power. So we have inelastic demand for necessities like electricity. The fourth characteristic is how broadly the market is defined. So if we pick something narrowly defined, we say demand is elastic. But if it's broadly defined, it's inelastic. And so the best way to explain this is with an example. So if we talk about the market for housing in Orlando, so all different types of housing, so apartment rentals of many sizes, condo rentals, home rentals, home purchases and mortgages. If we're just talking about the price of housing, if we say the price of housing in the metro Orlando area increased by 20%, we're kind of out of luck. It's a very broad market. And so we're going to have inelastic demand here because we have to pay for it. So if all housing is getting more expensive here because it's such a big market, there's not a lot of substitutes for having somewhere to live, we're going to have very inelastic demand as consumers. Now, if we narrowly define the market, so I take that same market housing and I take a little narrow subset of it, maybe this one luxury apartment complex downtown. And we say this one luxury apartment complex downtown, they increase their price, their rent per month by 20%. Now I can adjust my behavior. I'm going to not rent this apartment downtown. We're responsive, or we have elastic demand because I have a very narrowly defined market. So it kind of feeds back into that first characteristic of the idea of substitutes. The more narrowly we define the market, the more alternatives there are. The more broad we become, the less substitutes there are. And then the last characteristic is time. So as a consumer, the more time we have, the more responsive or the more elastic our demand will be. Over the short term, we don't have as much time to change our behavior. So if we go back to the market for gas, we said gas generally has pretty inelastic demand. However, depending on how much time we have to consider our gasoline purchases, our demand can become more elastic over time. So if we think over a very, very short term time horizon, so maybe the immediate run, you're on a trip, you're driving down the highway, you're in an area that you're not super familiar with, and your gas light comes on, you're going to stop at the first gas station you see, no matter if the price is high, low, whatever. We would say over that very short time horizon, you have inelastic demand, right? Because you're just going to stop at the first place you see. You're not really going to pay attention to price because you're on empty in an area you're unfamiliar with. Over a slightly longer time horizon, like during the week on your normal weekly commute, you see that you get down to maybe a quarter of a tank or an eighth of a tank, but you've got a little bit of time. Now you can kind of shop around, pay attention to those gas station signs as you drive by. Your demand is still pretty inelastic, but it's become more elastic than that really short time horizon where you immediately need to purchase something. And then over an even longer time horizon, maybe many months, many years, as the price of gas increases over time, maybe you make decisions like carpooling, opting for more fuel-efficient vehicles, or moving somewhere with public transportation. The more time you have, essentially, the more responsive or the more elastic the demand. Okay, so now we're going to move a little bit into the math section of things. So our definition of price elasticity of demand, or E subscript D for short, is a percentage change in the quantity demanded divided by the percentage change in price. So we write it as a little fraction, or sometimes called a ratio. So this fraction symbol is just an alternative for division. And we've seen these symbols before, but just to reiterate, this just means percentage. And this little triangle symbol, it's the Greek letter delta, and it's just a shorthand for the word change. So don't let these symbols intimidate you. It's just an abbreviation for saying percentage change in quantity demanded. And over here we have percentage change in price. So just some abbreviations to not have to write out this long word over this long phrase, right? So we're going to do some examples with this. Ooh, moved a little too quickly. So we're going to calculate price elasticity of demand. Let's suppose that you own a coffee shop and you're trying to attract more customers. So you, having taken an economics course, know that if you lower the price, the law of demand says you will sell more. And so as you're trying to attract more customers, you try manipulating the price of a cup of coffee you sell. So for 1 month, you lower your price by 10% and your sales jump by 30%. What is our price elasticity of demand? So I'm going to move over here. So elasticity of demand is the percentage change in quantity demanded over the percentage change in price. So if I plug in our numbers from the question, we said we start off with lowering prices by 10%. So the percentage change in price, we're going to say here is negative 10%. Now I have this negative sign here because the question says we lowered prices. So adding negative signs when we're talking about decreases or something lowering or falling is going to be really important here so we get the right answer. So make sure you pay attention to the direction here. And so when we lowered our prices by 10%, sales increased by 30%. So that's another way of saying consumers increased their quantity demanded, or the amount they bought, by a positive 30%. You can draw the positive sign out here, but it's not necessary. So if we simplify this, 30% over negative 10%, we will get an elasticity of demand of negative 3. Not so bad. That scary equation seems a lot simpler now. So we're going to talk about what that means. So first things first, elasticity of demand has no units associated with it. So here we'd say elasticity for your cups of coffee is negative 3. It's not negative $3. It's not negative 3 cups of coffee. It's not negative 3%. There is no unit here. It is a ratio. So we are just going to leave this. Elasticity is negative 3. And what that means is for every 1% price change in the cup of coffee, quantity demanded changes by 3% in the opposite direction. So here we would say the demand for coffee, not parking, sorry. I got this confused with the earlier example, or one I'm about to do here for you. We'd say this is very price elastic because my quantity demanded is changing by a lot, 3%, whereas the price only changes a little. So we're very sensitive, very responsive to the change in the price of a cup of coffee because people change their behavior, their quantity demanded by a lot when the price changes just a little. So we're going to talk about why it's negative. The reason the price elasticity of demand here is negative is because there is that inverse relationship between price and quantity demanded, that law of demand. When price goes one direction, quantity demanded will always go the opposite. And so put somewhere in your notes, it's in your concept guide too, you can highlight it. Elasticity of demand will always be a negative number. Here's why. So this right here is my equation for price elasticity of demand, percentage change in quantity demanded over percentage change in price. So if I have a decrease in price, or I have a negative number down here at the bottom, just like I did for this question, if I decrease the price, the law of demand tells me people buy more. So whenever I have a negative number on the bottom, I am going to have a positive number up top. That's because of the law of demand. When you put a positive number over a negative number, the result is always a negative number. But if we have the other scenario, what if instead you tried increasing prices at your coffee shop? Well, the law of demand tells me if I increase the price of anything, consumers buy less, which means every time I have a positive number on the bottom here, I'm going to have a negative number up top. When I have a negative number over a positive number, the result is still negative. So no matter what we're talking about, a price decrease or a price increase, the result is always going to be a negative number for this guy. So elasticity of demand is always, always negative. It's because of the law of demand. All right, so here's that parking example that I was talking about. We are going to do another example here. So let's suppose Valencia College parking increased parking pass prices by 50%. So they upped the prices by 50%. And as a result, people are going to buy less parking passes. Specifically, they sell 25% less parking passes. So if we plug those numbers into our equation, we're increasing the price by 50%. As a result, people buy 25% less. So we will have this negative number up here for the percent change in quantity demanded, because we're talking about people buying less. Negative 25% over a positive 50% is going to equal negative 0.5. So in this case, we are going to say that demand is inelastic, because I still have my negative number here because of the law of demand, but it's a small negative number. It's a decimal. It's 0 point something, right? That means here, consumers, maybe people like you and me who would buy the parking passes, we are not very sensitive to price changes. And that's because students, faculty, anybody who has to come to a Valencia campus is going to have to buy that parking pass. All right, now we're going to work some problems backwards, working with that same parking pass example. So we know parking passes has an elasticity of demand of negative 0.5, and the college is trying to reduce parking fees by 20%. What will happen to the quantity demanded? So we're going to plug in what we know and solve for what's missing. So I'm just going to move over to a clean spot on my little sketch pad. So again, elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. So for this first question, we're just going to plug in what we know. Elasticity of demand, negative 0.5. So elasticity of demand, negative 0.5 equals. And we're solving for this percentage change in quantity demanded. And we have the percentage change in price. We are going to reduce parking fees by 20%. So we're going to put a negative 20% down here. And we're solving for this missing term. So I'll just put that in parentheses. So to find this missing term, all we have to do is take this divided by negative 20% and multiply it over. So using your algebra skills, multiply both sides by a negative 20% times negative 20%. On this side, they cancel out. And so on this side of the equal sign, I'm left with the percentage change in quantity demanded. And now I've got a negative 0.5 times a negative 20%. If you type that into your calculator, you should get negative 10%. Or a positive 10%, right? Because two negatives equal a positive. My mistake there. Don't forget your negative signs. Kind of wasn't shaded in very well for me. So negative 20 times negative 0.5, we got positive 10%. So if the college reduces their parking fees by 20%, they can expect a 10% increase in sales. All right, now if we work it the other way, this second equation here says elasticity of demand is negative 0.5. the college would like to increase the quantity demanded of parking passes by 20%. What will they have to do to the parking fees? Okay, so similar setup here. We've got my elasticity of demand, negative 0.5. I don't know what my price is. They're asking me what do I have to do to the parking fees if I want my quantity demanded to increase by 20%. So I want sales to go up by 20%, so I have a positive 20% up here. So what do we have to do to parking fees? So if we plug this in here, I don't know what my percentage change in price is, but I'm going to multiply it over to the other side. So I have negative 0.5 times the percentage change in price. That's what this guy is. So maybe instead of, it's not wanted. This guy, I think, is what I want. Still kind of learning my tools here. There we go, eraser. My pen, percentage change in price. Multiply it over to both sides. So I move that term over and I've got 20% here. So we're going to divide both sides by negative 0.5. Divide this guy by negative 0.5. Cancels out over here. I'm left with the percentage change in price is 20 divided by negative 0.5. You should get negative 40%. So if Valencia would like to sell 20% more parking passes, they need to decrease their prices by 40%. So you should be able to work this equation different ways. All right, so we're going to relate this idea, our definition of elasticity, and define elasticity 5 different ways based on our definition and also introducing our equation here. So we said demand for something is perfectly inelastic if the price doesn't matter at all. So no matter what the price is, the quantity demanded does not change, and that means when we plug it into that equation, we're going to get the number 0 as our answer. So perfectly inelastic demand is kind of an abstract example because for most people and most goods and services, price is going to matter somewhat because we have budgets and we have ability to pay. But something is pretty close to perfectly inelastic if I would almost pay anything for it. So a good example of something you would almost pay anything for would be like a trip to the emergency room. You really, really need that. Or for me, I have a dog. I'm sure you've heard him in the background of a couple of these videos. If my dog was sick, he is my little fur child, I would pay almost anything to help make him better if he was very, very sick. So for me, whether the price of his vet care was high or whether it was low, whether it fluctuated dramatically, if my dog needed it, I'm pretty much going to pay for it. We have almost perfectly inelastic demand in that case. Now, realistically, generally we say demand is inelastic or it's relatively inelastic if price isn't very important. So it does matter somewhat, but not very much. So this would be the case for something like cigarettes. Now for cigarettes, price isn't very important to people who smoke them because they are probably addicted to the nicotine that is in cigarettes, and it is an addictive substance. So if price is not very important, we're not very responsive, we're going to get a decimal point number for elasticity of demand. So it's going to be negative 0 point something. It could be 0.3, it could be 0.5, like the parking pass example we just did, all the way up to 0.99. If it is somewhere between negative 1 and 0, we say that is an inelastic level of demand in terms of our equation. Now, you might hear some economics professors say that the elasticity is an absolute value. So we said elasticity of demand is always a negative number. A lot of times professors will just talk about the absolute value. So in this scenario we were just working here, where elasticity is negative 0.5, they might just say the absolute value is 0.5, right? So absolute value just means take away the negative sign because they're assuming you already know that it's always negative. So if you ever hear someone talk about the absolute value, it just means take away that negative sign. The next type of elasticity is unit elastic. So unelastic is where we get the number exactly -1 here for elasticity of demand. So the price changes exactly in proportion with the quantity demanded, and there's really nothing where we would always have perfectly unit elastic demand, where if the price goes up by 40%, I decrease my purchases by 40%, and any other percentage examples are perfectly the same all the way along a goods demand curve. It's kind of more, again, a abstract concept. It's kind of this middle point, but there isn't any good that has perfectly unit elastic demand. Okay, the last two types are elastic and perfectly elastic. So we say a good has relatively elastic demand if price is fairly important. This is the goods that have lots of substitutes, have narrowly defined markets, might be luxuries or big ticket items. Price is fairly important, which means we get a big number for our measure of sensitivity. It's going to be a big negative number, right, because this guy is always negative, but it's going to be greater in terms of magnitude than -1. So -1.2, the very first example we did with cups of coffee where we got the answer -3, that would be elastic, all the way to -infinity. And then the last, most extreme form of elasticity is going to be perfectly elastic. So we say a good is perfectly elastic if the price is everything. It is the only thing that matters. In that case, we say the elasticity of demand approaches infinity because nothing ever perfectly equals infinity if you're a math person. So if price is the only thing that matters for this item, we'd say it's perfectly elastic. The closest example I can come to would be currency. Think a $5 bill. If I were to try and sell $5 bills, there's pretty much one price I can charge. That's $5, right? If I try to sell $5 bills for $5.01, I'm not going to sell any, right? No one's going to want to purchase my $5 bills from me because essentially they'd just be handing me an extra penny. On the other hand, if I drop the price of $5 bills to $4.99, I can sell those $5 bills all day for $4.99. So I get infinite changes in either direction. There's pretty much one price, and if I vary from that price, I'm going to get infinite changes in the amount that I'm selling, the quantity demanded for that. So again, kind of an abstract example. The closest example would be currency, which is a little bit silly, but helps kind of illustrate the infinite importance of price in this scenario. All right, so a lot of times the equations we get when we're solving for elasticity of demand, we don't have everything measured in percentages. And the couple examples we just did with this equation where we talked about changing the sales of a cup of coffee or the sales of Valencia parking passes, we had the price changes measured in percentages, we had the quantity demanded measured in percentages, and we could just plug them right into this here equation and it would spit out our answer. Now, in reality, most businesses, when they're looking at their sales, do not have things in perfect percentages, so we have to turn them into percentages. So when we're calculating with elasticity, we create percentages using something called the midpoint method, and it is not the standard percentage change formula. This is the standard percentage change formula. It's pretty much what you use to find the percentage change in any variable, except for elasticity. That's going to be our exception here. And so the reason it's our exception is because it would create weird percentages. It matters where your starting point is. So imagine that you are buying or selling an item, and we talk about a price change between $100 and $80. The percentage change from 80 to 100 or 100 to 80 should be the same. However, using this formula, we get two different answers here. We don't want that, so we're going to use a different formula here. Now, if you're not familiar with percentage change, don't even worry about this slide. Don't fuss about this equation. This is just to avoid confusion among people who are used to calculating percentages. We're going to calculate the percentage a new way here using something called the midpoint method. So this is our new midpoint method. So to get the percentage change, or percent delta, right, this guy just means change, in any variable, we are just going to take the newer value minus the older value and divide by the average of that new and old value. So I know this looks very scary, but this is kind of our fully fleshed out equation here, just taking each of those ideas. So to find percentage change, to find the change in quantity demanded, we take the newer quantity demanded, we'll call it Q2, because it's our second quantity demanded, and we're going to subtract out Q1, our first quantity demanded, and then we're going to divide it by its average. So the average of two numbers is what you get when you add them together. So I have Q1 plus Q2, and we divide by the total number that we're adding together. Here we're adding together two numbers, so we divide by 2. So that's just, it looks scary, but it's just the change, subtract the new minus the old, divided by the average. That's percentage change in quantity demanded up top. Then we'll do the same for price. We'll take our change in price, take the newer price, P2, subtract out the original price, P1, and divide by the average. Add those prices together and divide by 2. And then we'll get percentage change in price. Once we get the top part and the bottom part, then we can go through and divide and get our final answer for elasticity of demand. So let's do an example. Let's suppose you are selling sandwiches. You have a sandwich shop, and originally you were selling sandwiches for the price of $6 per sandwich, and at that price you sold 15 sandwiches per day. So my P1 is going to be $6, and my Q1 will be 15. Now the new price, you try lowering the price, you drop the price to $4 a sandwich, and you sell more. Your new quantity demanded will be 25. So if I want to plug into this long drawn out equation here, all we're going to do is plug in our numbers for P1, Q1, P2, Q2. It helps to write them out. Okay, they will not always be written out for you and labeled P1 and P2 when you know exactly where to plug them in. They might be phrased in a word problem, just like I kind of verbalized it here for you. So go ahead and write them down, right? Which is your P1? Which is your P2? What's the corresponding Q1 and the corresponding Q2 before you try to plug them in? But plugging them in here, we've got the quantities up top, Q2, 25 minus Q1 of 15, divided by my average here. P2, the second price was $4. It was actually the lower price, right, because we dropped the price here, minus the original $6 price, and then divide that by the average, then add it up and divide it by 2. So if we simplify that, we get 10 over 20, and we get negative 2 over 5. Simplify that down one more time, you'll get 0.5 up here and negative 0.4 down here. You should get 1.25 as your answer. So if you're using a graphing calculator here, you can put all of these parentheses in here, type this in from the get-go. The only thing you'll have to remember is there should be another set of parentheses here around everything on top, and then another set of parentheses around everything here on the bottom in order for your graphing calculator to spit out the right answer. Otherwise, do it by hand, and you do what's in the parentheses first. And then you do what's on the top and what's on the bottom before you do that final division sign here. All right, so now we're going to put the definition of elasticity, our values for elasticity, and we're going to apply it to the idea of graphs and demand curves. Typically, the more elastic demand for an item is, we say that means we're more sensitive to price changes. We get a big negative number in terms of the value from our equation, and our demand curve will be flatter. When demand is inelastic, we say we are fairly insensitive to price changes. We get a small negative number here for elasticity of demand, and we get a steep-looking demand curve. So here are some examples. So this is a perfectly inelastic demand curve. So like I said, this would be like vet care for me. That means any change in the price along this demand curve, whether it's a low price or a high price, it doesn't matter. My quantity demanded stays the same, whatever this number is right here. This is a perfectly inelastic demand curve. It is so steep that it's gone completely vertical. Now, we said that wasn't very realistic. In reality, we see relatively inelastic demand curves. So this is a fairly steep demand curve for something like cigarettes, which means I can have a big change in the price, right? There's a big gap here between P0 and P1, so there's a big increase in price. And the result is a very small decrease in the quantity demanded. So we get a small number over a big number here. Now, if demand gets more elastic, our example was Brussels sprouts, that means I can change the price just a little bit, right? A little small change here. And I get a big change in terms of quantity demanded. So I get a big number over a small number. And lastly, we have perfectly elastic. So we have any change in price. There is one price that I can sell a $5 bill for. That's $5. Anything above it, I'm not going to sell $5 bills for $5 and a penny. Anything below it, I can sell infinite $5 bills, right? Extreme changes either way. So that's perfectly elastic, where price is everything. So a little bit of a trick for you is if you ever get the shape of the graphs confused, it's kind of a little bit of a trick. The perfectly inelastic demand curve, VETCARE, for me, was straight up and down. Kind of looks like the letter I for inelastic. So perfectly inelastic, the closer it looks like that letter I. Perfectly elastic, the $5 bill example, those demand curves are so flat that they're perfectly horizontal. Kind of looks like the letter E for elastic. So this is my perfectly elastic curve. This is my perfectly inelastic curve. Kind of looks like the letter I and the letter E. So a little trick for you to remember them. All right, so we just looked at demand curves with varying steepness. We said the steeper the demand curve is, the more inelastic demand is, and that the flatter a demand curve is, typically the more elastic the demand is. However, I do want to reiterate that the slope and elasticity are not the same thing. They are related to one another. However, elasticity is going to vary along a straight line demand curve, even though the slope would be the same. And so I want you to know this rule, that elasticity decreases as you move down and the right along a demand curve. Or we could say demand becomes more inelastic as the price drops. Or demand becomes more elastic as the price rises. And that's because of one of the characteristics of elasticity of demand, the share of the consumer's budget. It fits back in. So we're going to do a little example here. So if you are familiar with the concept of slope, it tells me how much the vertical value changes over how much the horizontal value changes. And here, this is a beautiful straight line with a constant slope of -1. So every change in price results in a change in the quantity demanded down here of -1, right? So price goes up by $1, quantity demanded goes down by 1. Vice versa. If I move this direction, quantity demanded is going to go up by 1. Now, I have constant slope here. It's -1 all the way, point A through point F. However, the elasticity is not going to be the same here. So this is going to be a chance for us to do more practice with that long version, the Q1s and the Q2s of that elasticity equation. So what I'm first going to do is calculate the elasticity of demand from point A to point B. So everything at point A is going to be my first price, my P1, and my point B will be my second set of price and quantities demanded. So we're going to start here at point A. So we're going to say the price at point A and the quantity demanded at point A. So at point A, the price is $5 and my quantity demanded is 0. So $5, quantity demanded 0. Then as I move to point B, At point B, my price is $4 and my quantity demanded is 1. So at point B, the price is now $4 and my quantity demanded at point B is 1. So now if I plug that into my elasticity of demand equation, I need the percent change in quantity demanded divided by the percentage change in price. So we're going to use my midpoint method. So we're going to use the second quantity minus the older quantity. So we're going to have 1 minus 0. And then we're going to divide that by the average. So the average is going to be 0 plus 1 divided by 2. And then we're going to do the same for price. So my new price is going to be $4. At point B, the price is $4. And the original price at point A was $5. So we subtract out the old price. And then we divide it by the average. It's going to be 5 plus 4 over 2. All right, now we just have to simplify here. So as I simplify this, I get 1 for that top part of the fraction. 1 minus 0 is 1. And then we're going to do everything in parentheses here. We're going to add these together. 1 divided by 2, that is 0.5. So I'm just going to write 0.5 here. Right? And then here I've got $4 minus $5, that's negative 1. And then we're going to divide that by my average. So my average here, 5 plus 4, that's 9, divided by 2, that's 4.5. Simplify that a little bit further here. If we do 1 divided by 0.5, that's going to simplify down to 2. If I do negative 1 divided by 4.5, I'm going to get 0.2222. If you're going to use decimal points here, go ahead and keep 4 until the end, and then you can simplify down to 2. So if you divide 2 divided by those 4 decimal points, I get a negative 9. This guy here is negative. So this is very, very elastic demand. So here, negative 9.1. Now we're going to do the same thing going from point B to point C. So now my starting point is all the data from point B, where the price was $4 and the quantity demanded was 1. And my new price and my new quantity is going to be at point C. So at point C, my price is $3 and my quantity demanded is 2. So we got $3 and 2. Same idea. We're going to take the percent change in quantity demanded up top. So my new quantity demanded minus my old quantity demanded. 2 minus 1. And then divide that by their average. 1 plus 2 over 2. Then we're going to do the same for price. The new price minus the old price. 3 minus 4 divided by their average. 4 plus 3 over 2. Simplifying that down, 2 minus 1, that's 1. Over the average, 1 plus 2 over 2, that is going to be 1.5. And then we're going to divide that. 3 minus 4, that's a negative 1. 4 plus 3 over 2, that's going to be 3.5. Simplify down a little bit further. We're going to do 1 divided by 1.5. That's going to be 0.6667. And then negative 1 divided by 3.5 is going to be negative 0.2857. So let's see. 2857. For that, next elasticity, I've got negative 2.33. Let's see what we get here. Negative 2.3. for this guy. So we went from very, very elastic, a really big negative number, to still pretty elastic, a still fairly big negative number, but not quite as big as the first one. And what you'll see if you want, and this would be great practice if you're still a little bit rusty on this equation, but I will not extend this video any longer by going through all of them. If you calculate down here, the next result should be a unit elastic, then a pretty inelastic number, we get negative 0 point something, and a very inelastic number, very, very close to 0. So as we move down my demand curve, demand becomes more inelastic even though the slope is constant here. All right, so now we're going to talk about how this idea of elasticity relates to a concept called total revenue. So total revenue is going to be discussed much more in detail in topic 2.3, where we talk about production and costs. But we're going to think like a seller here for a minute. If you are going to be a business owner someday and you want to open your own coffee shop or your own bar, or you want to sell property or whatever it is, it might be helpful to know whether or not the good or service that you're selling has elastic or inelastic demand, right? Whether or not your consumers care a lot about the price of what you're selling or a little, because that's going to affect something called your total revenue, which is the total amount you have coming in from sales. So the way we calculate total revenue from a business owner perspective is total revenue, or TR, is equal to the price of whatever it is you're selling times the quantity that you sell. So for example, if you sell 100 cups of coffee for $3 each, your total revenue is going to be $3 times 100, or $300 in total revenue. So we want to know how to maximize that total revenue as much as we can, and how changing the price of what I'm selling affects my revenue. So what I did is I took the information from that downward sloping demand curve that we were just looking at. It was the graph for skinny lattes. So we have all the points here along from point A to point F. So this is point A, B, C, D, E, and F along that demand curve that we just looked at. Same exact quantities demanded and their corresponding prices. You multiply them together, you get the total revenue here. So this is the new information. And then what we were calculating and we did together were these first two elasticities between the different prices, right? So as I move down the table here, as the price drops, demand is going to become more inelastic, and we want to see how total revenue corresponds to that. So here at the top where we have highly elastic demand, a drop in price from $5 to $4 increased my total revenue, right? Went from $0 total to $4 total. Then as I drop the price again from $4 to $3, my total revenue increased again, where demand was still pretty elastic. Here at the unit elastic level, this is where we stop doing our calculations here in this video, the total revenue stays the same as I drop the price from $3 to $2. And then for these last two, if we drop the price again by $1, where demand is inelastic, my total revenue starts going down again, and then it drops again if I continue to drop the price. So if I am a seller and I want to maximize the amount of money coming in, I maximize it at the point where demand is unit elastic. Now you might be thinking, hold on a second, we said there's no such good with unit elastic demand, and that's true. There is no good that has unit elastic demand at every single point along their demand curve. However, most demand curves, most products have some point at which demand is unit elastic for just a second, right? Just for a little bit of a price fluctuation. And at that point, that is where our total revenue is maximized. So that's an important rule. It should be in your concept guide, but make sure you write it down or highlight it, that where demand is unit elastic is where we're going to maximize that total revenue. So if I'm a business and I have a pricing strategy, we're trying to find this point. So generally speaking, here are my rules summarized. This is kind of the information from the table. If I have a product with elastic demand, that means my consumers care a lot and adjust their behavior based on the price, right? Because we're sensitive if demand is elastic. So decreasing the price is going to raise my total revenue because I can drop the price just a little bit and consumers buy so much more. So that ups my total revenue. Whereas if demand is inelastic, that means consumers don't care about the price. So I can get away with bumping up the price, and I'm not going to sell that much less. I mean, people will buy a little bit less, but because they have inelastic demand, I can up the price and still raise my total revenue because I'm selling those items for more now. At that point where demand is unit elastic, total revenue is maximized. You can fluctuate the price a little bit and you get proportional changes in quantity demanded. So we're looking for this point. So I have a little video here. It's from The Simpsons, an episode called Bart Gets an Elephant. So you can see how price changes affect total revenue here for Homer when he starts selling elephant rides and seeing the elephant. So take a look at that video, hit pause here, jump over to supplemental video tutorials for 2.1, watch the clip labeled Bart Gets an Elephant, and decide whether or not Homer has a service that is elastic or inelastic. All right, so hopefully you watched that video. As you can see, Homer raised the price and his sales evaporated magically. So we would say demand for elephant rides is probably pretty elastic, in which case he should not be raising the price. You should raise the price on goods that have inelastic demand instead. All right, now we're going to talk about our other types of elasticity, starting with price elasticity of supply. So this tells us how sellers respond to changes in prices. So the equation stays exactly the same, except instead of putting quantity demanded up top on that ratio, we are going to put quantity supplied. So this is the responsiveness of sellers to a change in price. We know when the price of the good or service that a seller is selling goes up, they want to sell more. And if the price goes down, they want to sell less. Price elasticity of supply tells us how much more or less. So there are two determinants of price elasticity of supply: flexibility of producers and time. So flexibility of producers, the more flexibility you have in terms of being able to produce more or less as a business owner, is going to determine how responsive you are to the price. If you are very flexible, it can mean one of these three things. So you have spare capacity, you can maintain an inventory, or you can relocate easily to where the price is better for you as a seller. So spare capacity means you have the ability, you have the capital equipment to up your production. It might be that you are producing a product that is rising rapidly in price and you would like to produce more, but maybe it requires heavy machinery that you do not have access to, in which case you do not have as much flexibility. But if you have that extra heavy machinery and you can hire more workers, that is spare capacity, and you can adjust your behavior based on the price of whatever it is you're selling much more easily. If you can maintain an inventory, have some extra, and sell it when the price is right, that's going to mean you have more elastic supply. Or if you can relocate, you can change your behavior. So basically, the more flexibility a seller has, the more responsive they are to the price. The less flexibility a seller has, the less responsive they are to the price, and we'll say that's inelastic supply. The second characteristic is time. So much like consumers, producers, the more time they have, the more they can adjust their behavior. So over longer time horizons, we'll say supply is more responsive or elastic. And over a shorter time horizon, sellers have pretty inelastic supply. All right, if we're going to calculate price elasticity of supply, it's going to be very similar. We can abbreviate it as E subscript S. So it's going to be the percentage change in quantity supplied. Remember, quantity supplied is the amount that sellers are able to sell over the percentage change in price. Now here is a fun rule about this term. So we said elasticity of demand is always negative because of the law of demand. Alternatively, price elasticity of supply, ES, will always be positive. And the reason for that is because of that law of supply. When price increases, sellers want to sell more, so we get a positive number over a positive number for this ratio. If the price of an item decreases, sellers want to sell less, so we'll get a negative number over a negative number for this ratio. Regardless of the direction the price is moving, this ratio will spit out a positive answer for elasticity of supply. It's because of that direct or positive relationship between my variables. All right. So now that we kind of have the idea of elasticity of demand, we talked about that in great detail. It corresponds to elasticity of supply. I want to talk about this idea called tax incidence. Okay, so tax incidence is the idea that if I tax something, who actually pays the tax at the end of the day? So, for example, let's suppose that because gas is bad for the environment and CO2 emissions lead to climate change, let's suppose our local government wants to impose a tax of 10 cents per gallon on gasoline sales. Who actually ends up paying that 10 cents? How is that 10 cents split between the buyer and the seller? And there's a misconception that whoever the government collects the tax from is who pays it, but that's not really the truth. What actually determines tax incidence is elasticity. So for example, I could collect the tax from the sellers. I could go to all the gas stations, pass a law saying, gas stations, for every gallon of gas you sell, you have to pay the government a 10-cent tax, right? So we are collecting the tax from the seller per gallon of gas. Well, sellers will probably respond by increasing the price of a gallon of gas. So even though the seller is paying it out of pocket, us as consumers, we are going to bear some of that tax incidence through that higher price. And vice versa, if we made consumers pay the tax, that 10-cent tax. So there would be the price that we see on the big glowing screens when we drive up to the gas station. We would fill up our tank, and then it would calculate how many gallons we used, and then on my receipt there would be the price I paid plus 10 cents for each gallon that I paid, and that'll be the total amount my card was charged as a consumer. I will adjust my behavior as a consumer by lowering my demand for that item, and that will lower the market price of gas, and I will try to pass as much of that tax burden as I can onto the seller. So this is very important for tax incidence, is it does not matter who you collect it from. Whether we collect it on the seller's end or on the buyer's end, we are going to try and pass off that tax incidence. What actually matters is which side of the market is more elastic. So the general rule are these 2 bullet points. If demand is more inelastic than supply, consumers are going to bear most of the burden. Vice versa, if supply is more inelastic than demand, sellers are going to bear more of the burden. So in the case of gas, we talked about how demand for gasoline is pretty inelastic here. If we pass that 10-cent gas tax and your government official were to say to you, don't worry consumers, we're not going to tax you guys, we're going to tax the gas stations, we should still be pretty frustrated as consumers because we know since demand for gasoline is pretty inelastic, sellers are going to respond probably by passing almost all of that 10 cents gas tax onto us in the form of raising prices by 10 cents because they can. Okay, so it's elasticity that determines tax incidence, not who the government actually collects the tax from. All right, so another interesting thing about tax incidence is we say the government tends to like to tax goods with pretty inelastic demand, so insensitive demand. So a good example of that would be the market for cigarettes. And the reason that the government will tax something with inelastic demand is because there's not a lot of substitutes. People do not change their behavior very much. That's what inelastic means. People are still going to purchase that item. So we say there's not much deadweight loss, or there's not much reduced economic activity. That's our fancy term for a decrease in demand. Because demand is so inelastic for cigarettes, because people are addicted to the nicotine, they keep on buying it, no matter how much that tax per pack is. And so that gives the government a steady, reliable stream of revenue. So we minimize the loss of economic activity, we minimize the deadweight loss, and we get consistent revenue. So generally speaking, if the government had a choice of passing a tax on something with elastic demand, like Brussels sprouts, or cigarettes, which has pretty inelastic demand, they're probably going to pick the inelastic good. They also have a tendency to tax goods that create negative effects externally. We know smoking cigarettes is not good for you, which is also another reason why they have lots of tax tied to them. All right, so there are 3 other elasticities that we're going to discuss briefly. Income elasticity, cross-price elasticity, and wage elasticity of labor supply. This last one is just kind of fun conceptually. These are the only 2 that you would have to know and calculate on an exam, but a lot of them reflect a lot of the similar ideas. So the first one we're going to talk about is income elasticity of demand. So we know that changes in income changes our demand for an item, right? When we get a raise at work or if we get fired from our job, we're going to shift that demand curve based on the supply and demand chapter. But what income elasticity tells us is how much. So the first thing I want you to know about income elasticity of demand, abbreviated EI, is that it can be positive or negative. So with demand and supply elasticity, they were only either negative for demand or only ever positive for supply. This one can go either way. It can be a positive number or a negative number. And whether or not we get a positive or a negative number actually tells us whether or not we are dealing with something that is a normal good or an inferior good, which is kind of cool. So if we have a normal good, so just a little refresher, a normal good are goods that move the same direction as our income. We're going to get a positive number for income elasticity here. On the other hand, if we have an inferior good, we're going to get a negative number. So within the category of normal goods, so we know if a good is normal, we'll get a positive number here. There are 2 different types of normal goods. There are necessities and there are luxuries. So both of these are normal, meaning we will get a positive number here. But whether we get a big positive number or a small positive number is going to determine whether or not it's a necessity or a luxury. So if I get a small positive number here, so I get 0 point something here for income elasticity, it's going to mean we have a necessity. Because when you think about it, necessities like toilet paper, groceries, things like that, I don't adjust my purchases of those necessities that much when my income changes. So I get a small number here. Versus luxuries like going out to dinner, going on vacations, travel. I change my quantity demanded a lot when my income fluctuates. So we're going to get a big positive number here for income elasticity. On the other hand, inferior goods, they're always negative because when your income moves one direction, your quantity demanded moves the opposite. So the example here that we used in the last topic or the few topics ago for an inferior good would be like ramen noodles. If you get fired from your job and your income falls, you're going to buy a lot more ramen noodles. So we get a positive number over a negative number, right? Negative income falling versus increase in the amount of ramen noodles I eat, and vice versa. If I get a big raise at work, I'm going to buy less ramen noodles. So no matter what direction my income's moving, for inferior goods, my quantity demanded moves the opposite direction, which is kind of cool. Cross-price elasticity. So this tells us something about how goods are related. So just like income elasticity, it can be positive or negative, and that's going to tell us something about how the 2 goods are related. So when we measure cross-price elasticity, there's my equation, we're going to measure how the price and the change of one good changes the amount I buy of another. So specifically, we're talking substitutes and complements. So substitutes are goods you use in place of each other. So instead of having good A and good B here, for a substitute good, let's see if I can move over here so you have some more space. So cross-price elasticity for substitutes, I could measure how does the quantity demanded of Pepsi change when I change the price of Coca-Cola. So this is percentage change in Pepsi, and this is percentage change in the price of Coke. So if these 2 are substitutes, if price of Coke goes up, I buy more of the alternative Pepsi, positive number over positive number, spits out a positive number for cross-price elasticity. Vice versa, if Pepsi is on sale at the store, I'm going to buy more, or if Coke is on sale at the store, I'm going to buy less Pepsi, negative number over negative number, still spits out a positive result. So for substitute goods, cross-price elasticity is always going to be greater than 0, or we get a positive number here. Now, complement goods, those are goods that you use together. So if I were to look at the cross-price elasticity of peanut butter and jelly, so I could look at how does the percentage change in the quantity demanded of peanut butter change when I change the price of jelly, I'm always going to get negative answers for this cross price. So if jelly is decreasing, it's on sale at the store, I'm going to buy more peanut butter, right? So I get a positive over a negative, that spits out a negative result. If jelly is really expensive, goes up in price, I don't need as much peanut butter to go with it, so I get a negative number over a positive number, still spits out a negative number here as a result. So for complement goods, we're always going to get a negative number for cross-price elasticity. All right, and the last one is wage elasticity of labor supply. So this is another elasticity of supply, so it's going to be a positive number, just like normal elasticity of supply. But we're looking at how the quantity supplied of labor, so this you could think of as the amount of workers who want to work or the amount of hours that a worker wants to work, so the quantity supplied of labor. How do we react as workers to the change in our wage? Well, we know the lower the wage, the less we want to work, and that the higher our wage, the more we want to work to a certain extent. So the interesting thing is how it differs between teenagers and adults. So we're definitely going to get a positive number here for either of these. But for teenagers, they're going to be more responsive to their wage elasticity of labor supply because they don't have bills to pay. So whether or not the wage is worth it is going to determine how much they want to work. A lot. So they're more elastic or they're more sensitive to the wage. Adults, if your boss comes to you and says, hey, look, I got to cut your pay. We're falling on hard economic times right now. Sorry about it. I don't change my hours that much. I mean, that is a bummer for me, but at the end of the day, I've got bills to pay. So for adults, their wage elasticity of labor supply is fairly inelastic. So we get a small number here for this ratio. So kind of cool. Again, elasticity just means sensitivity. So if you just measure the sensitivity of one variable in connection to another, you can get all kinds of cool stuff, cool little fractions or ratios in economics. So I hope that's helpful. Let me know if you have any questions, do some of the practice, and I'll help clarify things.